Welcome back to another episode of Christian Natural Health. Today I'm going to be talking about methylation and our toxic environment. The best known genetic mutation is still probably MTHFR, the central gene responsible for activating B12 and folate in a biochemical cycle known as the methylation cycle. The final methyl donor it produces is SAMe, S-adenosylmethionine, but an inefficient cycle can bottleneck at the inflammatory homocysteine step. A large percentage of the population has MTHFR mutations. Even those who don't carry the gene can overwhelm the pathway with a similar result. But presumably these genes have been in the gene pool for generations, and only in the last few decades have supplements even been available to address them. Yet those who suffer from a significant methylation backup often seem to need ongoing support. Why? And what did people do before? Just suffer? And spoiler alert, my worldview already tells me that the answer to this has to be no, so I went digging for another answer. I wrote once before, and I will include that in the show notes in the previous blog post on the many of the hormonal and neurotransmitter roles of methylation, as well as the fact that it's one of the liver's 6 main pathways for phase 2 elimination in the liver. But it has another much bigger job that's a bit harder to define. The body turns genes on and off, epigenetics, via methylation also. Specifically, methylation plays an important role in regulating the genes involved in the inflammatory process, turning on and off appropriate immune responses when needed. But in cases of chronic unresolved inflammation, the overmethylation response can itself become pathologic, accelerating biological aging as well as perpetuating the inflammatory cycle. Inflammation is never the original problem. It's always, at least initially, triggered by something external that the immune system perceives as a threat. But the more toxic the world has become, the more opportunities there are for this process to occur. Environmental toxins trigger an inflammatory immune response, helpful if the invader is completely eliminated, but leading to an ongoing inflammatory cycle if not. Heavy metals like arsenic, cadmium, lead, nickel, and mercury can trigger this process. So can solvents like polycyclic or aromatic hydrocarbons, PAHs, diesel exhaust particles, and endocrine disrupting chemicals like phthalates from plastics, BPAs, dioxins, parabens, and nonyl phenols. Plastics in particular are quite ubiquitous in our current environment. Some people suffer much more extreme exposures than others, and some are better than others at getting rid of the junk that comes in, but all of us are exposed. So inflammation leads to oxidative stress, which is what leads to altered DNA methylation. The body generates pro-oxidants as part of the inflammatory response, again, in order to fight against the perceived outside threat. At the same time, external pro-oxidants can cause damage to the body's tissues, and the body responds with inflammation in order to initiate the repair process. In either case, whether the oxidative stress comes from within or without, excessive amounts of it can trigger direct DNA damage among other tissues. As DNA is the site of epigenetic methylation, this process can interfere with the normal healthy functioning of DNA methylation, which can also drive perpetual inflammation. Gut dysbiosis and the methylation demand. Many processed food additives have been linked to leaky gut or increased intestinal permeability. Leaky gut may be a cause of dysbiosis, which is imbalance in the microbiome, or an effect of it, since an unhealthy terrain tends to invite pathogens. Glyphosate, which is the active ingredient in the herbicide Roundup, can directly create dysbiosis by poisoning good bacteria in the gut, while pathogenic organisms are more resistant. Effectively, glyphosate can tip the balance toward the bad guys. Both leaky gut and dysbiosis are a setup for SIBO, small intestine bacterial overgrowth, which tends to go hand in hand with gallbladder dysfunction, particularly biliary sludge. This is because bile itself is antimicrobial, helping to maintain the balance in the microbiome. All of this is relevant to the methylation story because phosphatidylcholine is a major ingredient in bile, and the process of producing it requires SAMe, the methyl donor produced by the methylation cycle. So dysbiosis, particularly SIBO, will often lead to a higher than usual demand for methyl groups. Glyphosate can also directly alter DNA methylation too. So bottom line, I am, for the most part, a less is more kind of a girl when it comes to supplements. My goal is to treat the issue and then whittle down the ongoing supplement list to just the bare essentials. I find it frustrating when a product seems to be necessary for the long haul, especially when it's correcting a genetic issue that our ancestors had no means of correcting. That suggests to me that either we're treating the wrong thing or our environment is dramatically different than that of our ancestors. In this case, I think it's largely the latter. Detoxification is certainly part of the solution here, and it should be an ongoing process for all of us. But I suspect that this is the reason why these days people with especially a homozygous, which is two bad copies, mutation of MTHFR, or a perpetually elevated homocysteine level might just need ongoing methylation support. So there's tons of studies that are linked in the original blog post for this. I will put that in the show notes. Thanks for joining me, and I'll see you next week.